And ladies and gentlemen, for the third topic on dam safety management, we will have three renowned speakers that are going to deliver their presentation. Firstly, please welcome Ms. Chiara De Amo, Energy Data and Policy Analyst of International Energy Agency, to open the session with presentation topic of hydropower dam safety management. Please, Ms. Chiara, the time is yours now.
Oh, thank you very much. Can you hear me?
Yeah, clearly, Ms. Chiara.
Okay, perfect. So good afternoon to everyone. Well, it's almost 9 a.m. in Paris, so good morning and good evening to anyone who is joining from different time zones. So I'm Chiara D'Adamo from the International Energy Agency, and it's a pleasure for me to join this workshop today. Next slide, please. So today I will focus my intervention giving a brief overview on the climate impacts on hydropower worldwide. And then I will present the key findings focused on the climate impacts on South and Southeast Asian hydropower, ending with outlining the measures to enhance the climate resilience of hydropower infrastructure. Why I'm talking about climate resilience in a dam safety management session? Because when talking about dam safety management, we should consider that climate change is putting energy security at risk globally, including the effect that climate impacts have on hydropower generation and infrastructure. Next slide, please. So climate change directly affects every segment on the energy sector. And these two graphs show the increase in global mean temperature and the increase in the number of days with the maximum temperature above 35 Celsius degree, which is a variable that is strongly related with heat waves. So the temperature rise is directly linked with more frequent and longer heat waves, the early onset of snowmelt and permafrost thaw, higher wildfire risks, and longer summer. So all these climate hazards have effect on different subsectors in the energy system, and in particular, glacial melt due to warming poses a threat to South and Southeast Asian hydropower. In fact, the Hindu-Kush Himalayan region constitutes the world's largest glaciated region outside the poles and provides the headwaters for the 10 largest rivers in Asia. And in this region, the snow cover has decreased and will continue to decrease in all climate scenario. Next slide, please. Another thing to consider, so besides the temperature rise, is the shift in precipitation patterns that could have also significant impacts on hydropower generation and led to a major drop in capacity utilization. This graph shows an interesting key point that climate impacts will geographically vary significantly. So we are here showing two different scenarios, a low emission and a high emission scenario. We can see that in some regions like Central America and the Mediterranean region, the climate conditions are expected to be drier, while in other regions like South and Southeast Asia, the climate conditions are expected to be wetter. Next slide, please. This table shows the impact that are expected to be worse without mitigating the greenhouse gases emission. So some impacts are likely to happen before the end of this century, and in particular, the impact related to the change in precipitation patterns, as we said before, the temperature rise, and also the impacts related to the tropical cyclones. Next slide, please. So this graph shows the exposure of the existing hydropower plants to the standardized precipitation index. So indicate that the 13% of hydropower plants would experience a drier climate in the last 20 years of this century in a high emission scenario, if we compare the results to the pre-industrial period, while 40% of hydropower plants could see a wetter climate. Next slide. This graph indicates the one-day maximum precipitation, which is a variable that is related to the flooding risk. And it shows that over 45% of hydropower plants could see a notable increase in one-day maximum precipitation. In a low-emission scenario, 64% of hydropower plants are projected to see an increase by more than 10%. Next slide, please. Tropical cyclone and associated heavy rainfall, floods, and landslides can also challenge the hydropower generation. In fact, tropical cyclone can increase the sediment, the floating debris, torrential stream flow, which can impair hydropower equipment, threaten dam security, and cut generation output. So the impact of tropical cyclones on hydropower generation may increase in the future due to the projected increase in the proportion of the intensity of tropical cyclones. Currently, the 14% of hydropower installed capacity is exposed to tropical cyclone, and 7% is estimated to be under threat of major tropical cyclone, so above category 3. Next slide, please. The International Energy Agency also conducted climate impact assessment for existing hydropower plants in different regions, such as Latin America, Africa, and South and Southeast Asia. And the reason why we focus on South and Southeast Asia is that, first of all, it is one of the most vulnerable regions to climate change. And as we said before, the hydropower sector in the region will be impacted by the changing climate, mainly because of the higher energy needs. And moreover, in the region, hydropower is expected to play an increasing role to meet the region's growing economic and energy needs. And currently, around 15% of electricity is generated from hydropower, with very high reliance in several countries, notable Bhutan and Nepal. Next slide, please. So our assessment involves estimating future annual and monthly capacity factors of over 490 hydropower plants in 13 South and Southeast Asian countries between 2020 and the end of the century. So focusing on South and Southeast Asia, the IEA assessed climate impacts on over 86% of the hydropower installed capacity in the region. And to derive the annual and monthly capacity factors per hydropower plant, the assessment developed a high-resolution global discharge map derived from 5 general circulation models and 4 global hydrological models. The assessment is also based on 3 different climate scenarios that led to different global average temperature outcomes. So below 2 degrees, below 3 degrees, and above 4 degrees Celsius. By comparing this climate scenario, the report aimed to present how the greenhouse gases emission are likely to impact the hydropower capacity. Next slide, please. Thank you. So the assessment shows that from now until the end of the century, the regional mean capacity factor is projected to decrease due to the changing climate condition by 3.7% in the below 2 degree scenario, over 5% in the above 4 degree scenario. The black dots indicate the average hydropower capacity factor of the selected hydropower plants, while the colored bars indicate the range of the result. So the darker colors show the range of the 60% of the results for South and Southeast Asia. And a comparison of these results for the 3 different climate models shows that greenhouse gases emission reduction could contribute to reducing the negative impacts of climate change on South and Southeast Asian hydropower, and the impact will not be equal across the region. In fact, from the next slide, the impacts of climate change are likely to be spread unevenly across the continent, leaving some plants more exposed to climate change than others. So all the 3 scenarios indicate that 2 sub-regions, the Indian subcontinent, which includes India, Pakistan, and Sri Lanka, the mainland Southeast Asia, so Cambodia, Lao People's Democratic Republic, Myanmar, Thailand, and Vietnam, will see a continuous decline in hydropower capacity factors until the end of the century. In contrast, the other 2 sub-regions, so the maritime continent, which includes Indonesia, Malaysia, and the Philippines, and the Himalayan region, so Bhutan and Nepal, show more complicated trends in hydropower capacity factor, with a drop in 2020-2059, and then a recovery in the latter 40 years of the century. Next slide, please. So South and Southeast Asia's climate concerns are particularly associated with rainfall and floods, which are closely related to the monsoon systems and tropical cyclones. So changes in precipitation will alter potential, generation output, peak level, and also the seasonal variability of hydropower. In addition, the increasing temperature and extreme heat episodes are considered to be the main driver of melting mountain glaciers, which can affect hydropower generation in mountainous areas. And moreover, not only the hydropower infrastructure, but also the electricity transmission and distribution networks need to consider the climate risks into planning and construction, because it's not only important the hydropower generation, but also how the electricity is then transported. Next slide, please. So the increasing stress from climate change highlights the urgent need for action by all stakeholders to enhance the climate resilience of energy systems. Climate resilience is the ability to anticipate, absorb, accommodate, and recover from adverse climate impacts. And it covers not only extreme weather events, such as floods, but also slow onset events. For example, the changing precipitation patterns or temperature rise. So climate resilience, by definition of the IEA, is made up of 4 parts: readiness, robustness, resourcefulness, and recovery. Readiness and robustness are more related to long-term planning, while resourcefulness is the ability to continue operation during immediate shocks, such as extreme weather events, and recovery is the ability to restore the system function after an interruption resulting from climate hazards. Next slide, please. So enhancing climate resilience has, of course, some benefits. For example, it can provide a cost-effective solution for energy security, minimizing the damages and saving costs from climate impacts, enabling the universal energy access contributing to achieving universal access to affordable and reliable electricity services, and also to support clean energy transition. Next slide, please. So there is no one-size-fits-all solution because of the wide range of different patterns and magnitude of potential climate impacts, but resilience measures can be categorized into soft and hard measures. Soft measures consist of strategies, policies, and actions related to the planning, operational management, and recovery of the hydropower system. For instance, power generators and product developers can better consider the potential impact of climate change when they design and plan hydropower plants. They can develop, for example, early warning systems to reduce the recovery time. Hard measures, on the other side, are associated with the physical hardening of assets, such as technical and structural improvements, and for instance, enhancing the reservoir capacity, increasing the dam height, modifying turbines, redesigning spillways. And in countries that are likely to experience more frequent and intense rainfalls in the forthcoming decades, the hard measure to prevent overflowing will be particularly important. For example, flood fences for power stations. Next slide, please. So without government support and policy signals, multiple factors could limit utilities from aligning with adaptation needs. But 4 policy recommendations to consider in order to develop climate resilient energy assets are, so first one, next slide. Thank you. So the build robust climate data and strengthen climate impact assessment. So a tailored combination of resilient measures based on systematic assessment of climate risk and impact will help countries and power plant operators to increase the resilience of their system. Moreover, a credible assessment of climate risk and impact will significantly reduce the cost of implementing resilience measures. So according to a recent study of World Bank, for example, a project to build a resilient infrastructure without appropriate data on climate hazard and exposure would cost 10 times more than a project with sufficient information on climate risk. The second recommendation is to integrate climate risk and resilience into project planning and construction. So as the region seeks to expand hydropower generation to meet its growing economy and energy needs, integrating climate resilience in new project planning and construction will be crucial. So governments can send a strong signal to service providers and developers by mainstreaming climate resilience in the entire process of project planning. The third recommendation is to build climate resilience. Next slide, please. To build climate resilience into hydropower operation and maintenance strategy. In fact, as hydropower plants age, they tend to become more vulnerable to climate change. And given that extreme weather events are likely to occur more frequently and with greater intensity, the design of old hydropower plants may not suit the changed climate conditions. So government can set guidelines or standards for project operators to integrate the climate resilience monitoring into operation and maintenance plans. The fourth recommendation, next slide, is to enhance regional cooperation to coordinate sustainable resource development. So regional cooperation is crucial among countries with major shared water resources as the South and Southeast Asia region. And in order to form strategies that are beneficial for all and to coordinate actions on water source development. And also to avoid that one country's decision to build new hydropower projects can have impacts on the neighboring countries, altering downstream water availability and the overall ecosystem. Next slide. So to conclude my intervention, the International Energy Agency is actively working on assessing climate impacts and enhancing climate resilience. We're committed to building and enhancing climate resilience, providing technical analysis both at global and regional levels. For instance, the IEA has released 2 weeks ago the report Climate Resilience for Energy Security, was released during COP. And it provides a comprehensive overview of the climate impacts and hazards facing the entire energy sector, so covering both energy supply, not only the power sector, but also fuels and critical minerals, but also energy demand. The International Energy Agency has conducted regional assessment of climate risk and impacts on hydropower generation in Africa, Latin America, and Southeast Asia, which are the results that are presented here today. And we also developed the Climate Resilience Policy Indicator, which is an assessment of the level of climate resilience of each country by comparing the level of climate hazard that the country is facing with its policy preparedness. So climate resilience was also included as a core element in other International Energy Agency's reports. Next slide. For example, the World Energy Outlook, Electricity Market Report, the Hydropower Report, and several country reviews. So if you're interested in this report, please visit our website. And next slide. Thank you very much.
Thank you very much. Thank you very much, Ms. Chiara, for such amazing explanation and recommendation on the topic. And thank you as well for joining us very early in your different time zone. Thank you. Next, I would like to invite Mr. Xu Xinfang, Division Director of Department of Electric Power Safety Regulation, National Energy Administration of China, to deliver the presentation of technical supervision on operation safety on hydropower dams in China. Please, Mr. Xu Xinfang, over to you.
Thank you. Can you hear me?
Yes, we can hear you, sir.
Ladies and gentlemen, good afternoon from Beijing. Thank you so much for joining this event. Just now, the experts and scholars talk about resettlement, economic development, recovery of livelihood, and benefit sharing mechanism, the case studies of multiple dams. I think I've learned a great deal from your presentation. Resettlement and economic development and dam safety are the key factors constraining the scaling up of hydropower projects. If you're not doing a good resettlement work, people will be unhappy. Your operation and maintenance would be affected. Dam safety is another constraining factor of hydropower development. If you have a major failure or accident, the result could be catastrophic. So the central government, local governments, the companies give a lot of attention to dam safety. So today I want to talk about hydro dam safety, technical supervision in China. So first, I want to cover 3 things. First, the status of hydropowered, next, please. the status of hydropower development and dam construction, Dam Safety Supervision and Management Agency in China. Hydro Dam Safety Technical Supervision System. Next. Okay, I want to show you that China has abundant water resources. A potential is 660 gigawatts. Currently, we already have 408 gigawatt installed capacity. And the data I'm using now and later, I know different people have different numbers, which is understandable. They're using different timelines, forecast, and standards, but more or less at the same level. We have several bases. I have indicated the positions, Jingsha, Yalong, Dadu, Wujiang, Yangtze River, Yellow River, etc. Just main watersheds, basins, everywhere on this map, but mainly in southwestern part of China.
In China, when it comes to installed capacity, next slide, thank you. When it comes to installed capacity, as of now, we have around 390 million kilowatt, accounting for 70% of total installed capacity in China, while it comes to the total output of 2021, the hydropower output stood at 1,340 billion kilowatt hour, accounting for 60% of total. Hydropower is the second largest source of power generation, only next to coal-fired power plants. So it really plays a very important role in China. Next slide. In China's power sector. As mentioned earlier, you would be able to see the change of installed capacity ever since 2000. And the bar reflects annual increase of installed capacity, while the curve is reflective of the total capacity in operation. As of 2021, you would see the total indicated here at 390 million kilowatt hour. And we have seen a few peaks in these past 20 years or so. Last year was another year when we see a great increase. Next. Coming to part 2, Dam Safety Supervision and Management Agency. Next. In China, dam safety is supervised and managed by different agencies. As of our latest statistics, we have 98,000 dams of varying sizes for varying different functions. It is under the jurisdiction of different departments, and out of them, 42,000 of them have power generation functions. They are under the administration of Ministry of Water Resources, National Energy Administration, and MOHAD, the Ministry of Housing and Rural Urban Development. And under National Energy Administration, we supervise 657 hydro dams. Most of them are for power generation purpose. Those on the Ministry of Water Resources have functions of flood control, irrigation, water supply. Next. The Ministry of Transportation mainly supervise dams that have transportation functions for navigation purpose. And additionally, we also have a limited number of dams that are serving for the purpose of sediment retention or tolling. Next. Well, Ministry of Water Resources, as a competent authority, has the overall responsibilities over dam safety. So our department keeps a regular communication with Ministry of Water Resources. And under its ministry, it has different river basin authorities, including the one for Yangtze River, for Yellow River, for Huai River, Hai River, Pearl River, Songliao, as well as Taihu Lake Basin. Next. Yes. The National Energy Administration worked with the Ministry of Water Resources. Of course, we have a different approach to the supervision of dams, mainly because the target of supervision are different between our two departments. For the Ministry of Water Resources, they have local government branches at the provincial level, municipal level, and the county level. Each has a direct supervision over their local dams, but those dams under our jurisdiction are not directly managed or monitored by us. The companies are the main entities responsible for operations. We only exercise supervision. Next. So for the National Energy Administration, we mainly supervise dams safety through the following functions. We have set up a larger dam safety supervision center established in 1985. Initially, it was established under the Ministry of Energy. Back then, it's mainly responsible for technical supervision and supporting services from a technical side to support the National Energy Authority in delivering its dual tasks. And we mainly look into different stages, for instance, plan and construction stage. One of the organizers for today, CRE, is involved in not only the planning, but also planning review as well. Another department called Hydropower Engineering Quality Supervision Station is responsible for the supervision during construction phase. In the meantime, we have the agencies, what we call dispatch agencies, directly affiliated to NEA. They are essentially representative office of NEA at the local level to supervise local activities. And during the operation stage, it's mainly the supervision is carried out through the Larger Dam Safety Supervision Center of NEA and our dispatch agencies. Next. Next, thank you. Next. We cover the full life cycle of dams, not only the 18 dispatch agencies are involved in the process. Local and provincial energy authorities are also responsible for the 657 dams. I'd like to particularly highlight the fact that when dams have power generation functions, they would need to schedule their operations according to the need of the grid. But when it comes to the flood season, these dams would also need to subject their operations to the Water Resources Authority. So in other words, if the decision made by the power authority is in contradiction with the Water Resources Authority during flood season, then the decision of the Water Resources Authority would prevail in an effort to ensure safety of dams. Now, I'd like to also introduce the hydro dam safety status of dams under our supervision. I mentioned earlier that we have more than 98,000 dams around China. Among them, or more than 40,000 have power generation functions, and the installed capacity stood at 391 gigawatt with a total reservoir storage capacity of 9,306. Sorry, 93 billion cubic meters, and most of the dams under our supervision are large in size. They account for 79% of total installed capacity in China and 55% of reservoir storage capacity. In other words, all of the dams under our supervision could not afford to suffer any dam break. So ever since we have taken over the supervision of these dams, we have never seen an incidence of safety failure of dams. Next. Coming to part 3, I'd like to also share with you the technical supervision system in China. Next. Starting with a complete legal and a regulatory system for hydro dam safety. We have multiple legislations that involve dam and hydropower station safety, including water law, food control law, work safety law, administrative licensing law, emergency response law, and structural-wise, we have a well-established system of legislation as well. When it comes to regulations, they're released by State Council, and we have regulations on the administration of reservoir dam safety, flood control, electric power supervision, emergency response, and many others. Next. At the departmental level, we also have regulations that made provisions on supervision and administration of power generation, reservoir seismic monitoring, and they are also supported and complemented by industrial standards and technical standards, providing basis for our monitoring and operation of dams. Next. Previous slide, thank you. For responsibilities and how it's allocated across different departments, NEA is fully responsible for the planning, construction, operation, safety management of hydropower dams. And my department, Department of Electric Safety Supervision, mainly looks into work safety, reliable management, emergency response, and safety supervision. We are also responsible for involvement and investigation of work safety accidents. But as of now, we haven't seen safety accidents or dam breaks, so we haven't yet carried out any investigation of accidents. Next. Larger Dam Safety Supervision Center was briefly touched upon earlier. It's responsible for providing technical supervision services and management for the operation of hydro dams. This is a center that has 60 staff working under different divisions, some responsible for safety supervision, some for digitalization, some for emergency response. And for many years, the center worked closely with our departments under NEA. We had frequent exchanges and coordination between one another. So we have already built a well-established system of procedures between two sides. And for dispatch agencies, they cooperate with the local competent authorities in carrying out safety supervision and management of hydropower station. We have 31 provincial level units, but we only have 18 dispatch agencies directly affiliated to NEA. We have a total of 500 staff under dispatch agencies. But under each agency, they have a safety division. We have a total of 80 staff around China responsible for safety supervision. But of course, on top of that, we have local competent authorities at provincial level, municipal level, and the county level. They would also have the competent bureaus within the local government offices. They would coordinate with our dispatch agencies in carrying out management and supervision. So vertically and horizontally, you will have a well-connected and coordinated system in operation next. Now, I'd like to also share with you the 4 components of this system. NEA is responsible for general supervision and management. The local agencies and the competent authority at the local government are responsible for their regional supervision. The large dam safety supervision center provides technical supervision and several services, and the power enterprises are those who take on main responsibility. So when it comes to safety, power enterprises are still the main player, because when it comes to the design, the operation, particularly the day-to-day operation and the maintenance of dams, it comes all down to power enterprise. So they are the entities that are most familiar with the status of each dam and its surrounding environment, and they are also the one who will be held accountable. So for those power stations, dams that are truly able to deliver on their due responsibilities, usually the dams under their operation are of also good performance. Next. The images are not coming through. For us, hydro dam safety supervision is exercised through 4 means. Firstly, registration. Secondly, regular inspection. Thirdly, emergency monitoring. And fourthly, monitoring management. And on top of that, we still have a special inspection in place as a mechanism. If a dam has just experienced a recent emergency or a disaster, we would re-evaluate the status of dam. For instance, if there's severe earthquake or a flood that exceeded the design criteria, or those unstable changes to the banks of the the site, then we would need to carry out a special safety evaluation of the dam. That's what we call special inspection. But in recent years, we haven't been carrying much of such special inspections, mainly thanks to the regular efforts we've taken. Next. Next, yeah. For registration process, we have acceptance of submission of documents, on-site inspection, scoring of the site, and generate a review assessment and a review and assessment document. Usually, when we carry out the on-site inspection, depending on the size of the dam, we would need 3 to 5 experts to carry out such inspection, which usually lasts for 15 days. And at the time of registration, such on-site inspection is mainly targeting at management procedures and the status of the dam. But for regular inspections, we would be looking at the operation status. So for these two different types of inspections, at the time of registration, we mainly look at the management side of things. But for regular inspection, we would look at the operation, particularly safety status of the dam.
Remote surveillance. Timely, accurately send out the safety information. The company will need to submit to us the safety data and also to assess the operational state in real time, remotely, early warning and red flag of abnormalities, and to, in real time, understand the impact from flooding, typhoon, geological hazards, and earthquake. Next. Registered dam number from 1997, 94 only, and now we have 657 dams registered. It increases every year. Currently, in the next couple of years, the pumped hydro stations will develop very fast. We will have a big jump of registered number in future. Next. The safety registration. We actually, after the project completion, you can register for safety data. Once you are scored for the safety level, then the construction is considered accomplished. We have set up the registration filing system. Filing means that the electricity companies need to submit the data to NEA, the Supervision Office of Dam Safety Management, the registered and the dam fired with the NEA. They are managed differently, but our safety requirements are consistent, are the same. For those dams who are not registered with us, we don't really have routine check over them. Currently, we manage 657 dams. 603 are registered. 54 are only fired in our system. The registration process, next page. So basically the companies, they, after completion acceptance, they apply for registration. The Dam Management Center will send people to the site to inspect and check. On-site inspection follows very rigorous assessment system. It has several dozen indicators to go through, and the dam is scored for each item. The total points is 100, and if you pass 80 points, you will be registered in the system with a certain safety rating. 80 to 100, 1 score, 60 to 80, 1 score, and below 60, you're not allowed to register. Next. Currently, the safety registration has 3 levels, A, B, and C. A and B levels are normal dams. C is a sick dam. Currently, we have 560 level A dams, 41 level B dams, and 2 level C dams. The 2 level C dams are in Sichuan province, Rendonghai and Huashan dams. They had some depression of the dam body, and also they have a permeability. Currently, they are built, or the hazards are removed, but still, they need to be tested by a main flooding season. And the committee will go back to the 2 level C dams and make a second evaluation. All the registered dams are managed dynamically. Level A registration is valid for 5 years. So after 5 years, you need to get another on-site check to evaluate your safety. Level B and C certificates are valid for 3 years. Next. And we also have categories and the dams, dam height, and other parameters. Currently, gravity dam is the biggest one, followed by earth rock-filled dam, arc dam, other, and buttress dam. The height, 30 meters, 30 to 70, 70 to 30 to 70, 233, the biggest share. We also have a lot of very high dam. We have 13 dams over 200 meters high. Next. And installed capacity. So we have those at about 50,000 kilowatts because we have installed capacity and reservoir storage capacity. They are managed by different offices, but historically, my office manages some smaller dams. You can see on the left table, less than 10K kilowatt and less than 50 kilowatt, 1,000 kilowatt, altogether 40 of them. They are very small dams, but historically managed by us. For storage capacity, less than 1 million cubic meter, 82, very small one. 1 million to 10 million, 97. 10 million to 100 million, 176 dams. 100 million to 1 billion cubic meters, 179, more than 1 billion, 69 dams. So these are really big reservoirs. Next. I talk about safety registration situation of the dams. Now, I want to talk about routine inspection of the dams. In principle, every 5 years, we will carry out 1 round of compulsory dam safety inspections. Currently, we have finished 4 rounds of safety check. Currently, we are in the process of having the 5th round of inspections. Based on the inspection results, the dams would be classified as normal dams, faulty dams, and dangerous dams. Normal dams, we just use the early warning system to monitor them. For the faulty dams, often they have a major hazards, we would give them a period to correct the situation. The owners need to have a specialized team and have a rectification plan, and they need to be studied, approved, and start construction. And then the results will be verified. And for the dangerous dams, those are really dangerous, risky dams, we will lower the reservoir level. And even some, once the reservoir water level is lowered, there's still extreme weather, that they will simply be demolished. Currently at NEA, we only have 240 dams. We don't have any dangerous dam in the system, in our system. Next. Next, please. Thank you. Effective monitoring and security monitoring to supervise and instruct the hydropower stations to submit safety data. They can just do it remotely. They can have annual report and a special report. So basically, all the registered dams need to have a remote reporting system. That is our target. Currently, we don't really have a consistent system. Some are just using automatic notification system. Some are sending us documents. Some are sending facsimiles to us because they were built in different periods of time. They sometimes don't really have very advanced IT technology. Some are really old, and some are doing this manually and not really automated. Online monitoring system. This is advanced system we want to push. For the height, dam height over 100 meters, reservoir storage over 100 million cubic meters, they need to set up online monitoring system. Basically, we have different sensor points, and we collect data, put them together, and use the software program to make overall judgment and make a decision regarding the safety status of the dam, which is a critical component of IT-based dam safety management system. This is the major task we are pushing today. And in the dam management office, we have set up a platform for the safety surveillance of all dams. On this platform, you can get real-time safety data from all dams. And if you see early warning or red flag, the system will send an alert. Next. Now here you can see the system. The green dams are those registered or fired in our system. And you can see southwestern part of China most. Every dam will set information to us. Our monitoring platform is in Hangzhou of Zhejiang province. Next. Safety surveillance. Once we have the system, we have achieved good functions. The companies, their people mobile phone, we can input their mobile phone number in the system. If we see a key issue or a geological disaster, the system will automatically push the data to their managers, their local government officials' mobile phone, and the owner office mobile phones. So basically what happened, or like a natural disaster hit, what time, if like within 20 kilometers radius, 100 kilometers radius, whether the dam is located near this natural disaster zone, the epicenter, for example, the information will be pushed to them. And the inspectors, authorities, government officials, the owners, they need to check, right? They need to check the status of the dam to see if they are affected. So this is a very fast information push system. Next. emergency response management. We believe that really the dams need to have good preparedness for emergencies. So if there is an accident or major natural disaster, if you have a good emergency preparedness plan, you can really minimize the loss and impact on the grid. Currently, the emergency management system has the following components. We have set up the emergency preparedness action plan. It's a kind of industry standard, in fact. And also standardize the enterprise to enforce the emergency plan. And basically we give them the table of contents. They just fill in the details. And also assist and instruct them to effectively perform emergency check. In our routine management, we inspect their enforcement. Currently, the emergency plans, all the dam owners have the plan. They have an overall plan and a specific emergency response plan. So their system is very mature. But in some localities, some companies, they do have plans, but the plan is very superficial, not very complete, not comprehensive. Sometimes they listed actions which are not really valid or effective. So in future, we would urge them to improve their plans. Also instruct them and organize accident or post-accident management. If there is an onset of a major flooding or big earthquake and other natural disasters, NEA would work with ministries and send out working groups to go to the site to help local companies and the governments to deal with the disaster. Next, please. And also effective monitoring and incident monitoring. On the top left, you can see if we have an earthquake, and we will know immediately the epicenter of the earthquake and how many dams under our purview are covered within a certain radius. Information would be pushed to the managers and the local authorities. If we have a major natural disaster, we would work closely with other ministries. All the information is shared among the ministries. And also at NEA, we also push the dam information to other ministries. So it's an interministerial information sharing mechanism. Currently, the system is initially set up, but sometimes the information sharing is not very timely and sometimes inaccurate. I'm sorry, I spent too much time. I talk about the safety management of dam in China. To ensure their safe operation, you need to focus on 4 areas. First, you need to have integrated supervision and management organizational system, laws, regulations. Second, you are having more and more dams, but you don't really have a lot of managers or officials doing this thing. Make sure that you use IT system and a smart system to deal with the management workload and make good use of special and professional talents of the CREI or other think tanks, for example, like the CSHE and other institutes. And thirdly, you need to have a very powerful construction task force and emergency search and rescue team. And if you have high quality construction at the very beginning, you will have a good dam starting from day 1, and then later it will show a very high safety level. And also you need to have emergency response, search and rescue people. We have specialized search and rescue teams and some other companies. like the China Power, they have very strong search and rescue emergency response teams, and those are indispensable resources. Okay, thank you very much.
Thank you, Mr. Xu Xinfeng, for sharing the presentation. Next, please welcome Dr. Zhou Xingbo, Deputy Division Director of China Renewable Energy Engineering Institute, to deliver the last presentation for this event with the topic of the safety design and engineering practice of hydropower projects in China. Please, Dr. Zhou, the time is yours now.
Okay, thank you. Can you hear me?
Yes, sir, we can hear you.
Okay, good afternoon, everyone. I'm Zhou Xingbo from Korea. I'm very glad to have this opportunity to share the dam safety design and management in China. I have a lot of slides, maybe 35 pages, and it may be necessary to 10 pages faster. And my presenter, the slides I counter to see.
Excuse me, Monica, could you please share the, yeah, thank you so very much.
Yeah. Okay, let me go on. My presenter title is the Safety Design and Engineer Practice of Hydropower Project in China. And next page. There is 6 parts in my presentation. Yeah, next page. Part 1, determination of project scale. There are 2 aspects. Next. Determination of normal water level. We should consider the main factors such as safety, technology, benefit, and so on. The special report and review for the normal water level and the purpose is to determine the reasonable scale of the project and coordinate the relationship between hydropower development, resettlement, environmental protection. Next page. The main purpose of the 3 golden projects is flood control, electricity generation, shipping, irrigation, and so on. Next. During decision process, the demonstration is mainly a study on the selection of normal water levels from 1 to 8 meter to 260 meter. We should balance the comprehensive benefits and in addition loss. Finally, the normal storage level was 175 meter. Next. Number 2, design of the dam freeboard. We consider the main factors include dam grade, using condition. The dam height should meet different operation conditions. In the earthquake year, the height should be increased, especially for earth dam. Next. For example, Shuangjiangkou project in Dadu River, the crest elevation determined by the code is 2507.81 meter. However, an additional 2 meters of dam height was added to ensure the dam safety. So the final dam crest elevation is 2510 meter. Next. There is an anti-wave wall with the height of 1.2 meter. The highest water level of the reservoir will not exceed the crest of the dam, even in extreme cases, such as the occurrence of a 50% increase of the PMF, or the failure of the spillway tunnel when PMF occurs. Next, part 2, flood control standards. Next, determine the flood control standards. There are 3 steps. Determine the project rack, the hydraulic structure grade, choose the flood control standard. Next, determine for the project rack, we should consider project scale, storage capacity, install capacity, flood control such as population from that year, the importance of towns, industries, and minor enterprise. And next, For the hydraulic structure grid, there is a corresponding relationship with project track 2 to 5. There are also some special requirements. In brief, the higher the dam, the higher the flood control standard. Okay, next. Choose the flood control standard. We consider the main factors such as hydraulic structure grade, dam type, theory of the air, operating conditions, potential consequences. Next. For example, the Czech flood standard of Xiluodu project in Jinsha River, according to the code, the return period is 5,000 years, but the actual standard, the return period is 10,000 years. The main reason Xiluodu Dam is actually high, nearly 300 meters. The storage capacity is extra large, and it is the control reservoir in the river basin. Next. Part 3, selection of dam site and type. Next. Dam site comparison may consider hydropower utilization, geology, project layout, construction material, conditions, environmental impact, and so on. We should carry out comprehensive technical and economical comparative demonstration of each dam site, and finally select the dam site. Next. For example, the initial dam site of Houzian project in Dadu River is the low dam site. In the picture, maybe the right, maybe there is a circle. But during the comparison process, the nearly Kongyu town have about 300 people in the low dam site plan. The resettlement is very difficult, so the selected dam site is the up dam site. Okay, next. Dam type selection may consider geology, project layout, dam type, adaptability, construction conditions, and so on. Usually, the dam type was selected after technical and economical comprehensive comparison and demonstration. Next. Such as Iabatan project in Jinsha River. During the pre-feasibility study stage, we choose the CFRD. Next, but during the feasibility study stage, we finally choose the concrete arch dam. Due to the real cause, the layout of the flood discharge structures and investment. The next. The same to the lava project in Jinsha River. During the pre-feasibility study stage, we chose the RCC groundweight dam, but during the feasibility study stage, we finally chose the CFRD with dam line 1, just in the low picture of the right, maybe the dam line 1. Next. The main reason include geology conditions, the stability of project slopes, and the invest for the lava project. Okay, next. Part 4. Structure design of dam. There are 3 dam types. Next. For granite dam, during the section design, materials mechanic method and finite element method are usually adopted. Next. Both anti-slide stability and dam foundation bearing capacity and seepage control design are very important for the gravity dam. And next. For example, the Huangdeng RCC dam is 203 meters high, and when it is stored to the normal storage level, the total seepage, seepage amount is very less, so it's very safe. And next. For arch dam, during the ship design, arch beam load sharing method and finite element method are usually adopted. Next. And abutment stability against sliding and overall safety are also very important for arch dam. Next, such as the Jinping concrete arch dam, which is 305-meter high. For the safety design, a series of measures are adopted, just as the concrete grade replacement, resistant body, consolidation grouting, and so on. And next, under the normal storage level, the radial deformation of the dam body is normal and safe. Next, for embankment dam, during dam slope stability against sliding, the simplified Bishop method, Swedish arc method are used. The safety reserve is about 1.3 times. And next, dam seepage control and stress and deformation analysis are also very important for embankment dam. Okay, next. For example, 水不亚 face-rocked dam is 233-meter high, and it was stored to the normal storage level in 2008. The seepage in the past 5 years has not exceeded 50 liters per second. The maximum sediment of the dam body is accounted for 1% of the dam height. It should be safe. And next, part 5, seismic design of dam. There are 3 aspects. Next, for the precepts of the seismic design of dam, we adopt the precepts such as fortification by type and fortification by level. In general earthquake areas, the design earthquake adopt one level, such as return period of 500, 1,000 or 5,000 years. In strong earthquake area, the fortification requirements for check earthquakes are added. Okay, next. Seismic safety assessment is very important for dam safety design. It is necessary to establish a finite element model that reflects the interaction between the dam foundation reservoir water system. And next, for example, Dagangshan Arch Dam, the project area is 8 degrees, maybe the higher the seismic. The designed seismic peak acceleration takes exceeding probability of 2% within 100 years-based periods. Next, a series of seismic measures were adopted to improve the safety of arch dam, such as no spillway hole, beam director, asymmetric reinforcement of dam face to improve the dam safety of arch dam. Okay, next. Part 6, management of dam safety for the whole lifespan. There are 2 aspects. Next. Dam safety management should be throughout the whole life cycle, such as the plan stages, design, construction, operation, and the retirement stages. So the next page. And the design of the reservoir discharge is very important for the management of the dam safety in the whole life. Such as so through the reasonable layout of discharging facilities and water levels to meet the requirement of the maintenance and the risk are controllable in extreme disaster. The purpose of the final purpose is no dam break events. Okay, next. It's a case study, maybe the Fenman hydropower station. The new Fenman hydropower station has been rebuilt, but it was built in 1937. but there are some serious quality problems in the dam, and the risk is extremely high. For the picture, the left we can see dam surface phased after the liquid, and the corridor water sprayed in the dam in the middle picture. And the right picture, we have the reinforcement refers to the dam surface, but the safety maybe we have much more measures, but the risk extremely high. Next. So in China, we decided to rebuild the Fenman hydro dam. In June 2013, the construction of Fenman new dam started. In October and 2018, the old dam was demolished. In May 2018, the new dam blocked the water. The construction will be completed in September 2020. Under the left picture may be the new dam construction, and the middle picture is the old dam demolition. Maybe they're exploring. And the right picture, water field between the new dam and the old dam. Okay, next. I think, finally, project safety is the foundation of the sustainable development. So I think better dams, better life. Thanks for your attention. That's all.
Thank you very much for the amazing presentation, Dr. Zhu.